In this unit, we are focusing on exponential functions. In this lesson, we're going to focus on the key features of exponential functions and basically get a background on them before we start really diving in. So the first part here is, first example, what are the key features of the function? Include domain, range, intercepts, asymptotes, and end behavior. So we're going to look at f of x equals 2 raised to the power of x. So as you can see, this function curves up from left to right. So you would consider this an increasing function, because it's from left to right going up. Key parts here. An exponential function is any function of the form y equals a times b raised to the power of x. So in this example, b is your 2 is your b value, right? 1 is your a value because you don't see it there, right? Your a value ends up being your y-intercept in this function. The other thing that we're going to notice is the asymptote is the x-axis. And behaviors as x approaches negative infinity, so meaning as x goes left, y approaches 0, meaning this curve is flattening out at 0, but it's never going to touch it. The end behavior as x goes to infinity, so as x goes to the right, y goes to infinity, meaning y just goes up, right? This is considered exponential growth. Flip side is when you have a function going down. So this is considered an exponential function, but it's considered exponential decay. The reason is the b value is less than 1. So when the b value, the base of your exponent, is between 0 and 1, it's going to go down, and it's going to look more like this one. When the b value is more than 1, it's going to look like the previous example a. B can never be exactly 1, otherwise it'd be a flat line and it would not be exponential. B can also not be negative. So it's either between 0 and 1 or it's greater than 1. This one, the end behaviors are essentially the opposite, right? As x approaches negative infinity, so as x goes to the left, x approaches infinity, meaning it goes up. As x approaches infinity, meaning as x goes to the right, y approaches 0, meaning it flattens out at an asymptote of y equals 0. In this case, the y-intercept is 5, which also matches your a value. So in this example, you have f of x equals 4 times 0.5x. So the first thing I'm going to do, the a value represents your y-intercept, so I'm going to zoom out, go to there, and move the y-intercept to 4. Now I need to know where this other point goes. At this point, I think the best thing to do is, let's just plot a point. So we're going to pick an x value. Let's do an x value of 2, just because now we're the grid lines have been scaled to 2 units per line. So let's do f of 2, just to get another ordered pair to plot. So then you'd have 4 times 0.5 raised to the power of x. When we're evaluating for 2, that means the exponent is now 2. So 1/2 times 2 is 1/4. So you're going to end up with 1. So the ordered pair would be x is 2, y is 1. So we're going to have to move that point down, because right now it's at 2, 2. We're going to move it down to 2, 1. So right about there. All right, so what are the domain, range, intercepts, asymptote, and end behavior of the function? Okay, so let's go through all that. Domain x goes forever to the right, x goes forever to the left. So domain is all real numbers. Every exponential function is going to have a domain of all real numbers. Range It goes up forever in this direction, right? And it flattens out at 0. So it's going to be all the y values greater than 0. If you wanted the interval notation to be 0, comma, infinity. So it's 0 on the bottom, infinity going up. We're not including 0 because it's never going to touch 0. So it approaches 0. The intercepts. The y-intercept is 4. The asymptote, again, it's flattening out at the x-axis, so y equals 0. And then end behavior. As x approaches negative infinity, y approaches infinity, meaning as x goes left, the y goes up. As x approaches positive infinity, meaning as x goes right, y flattens out at 0. And that's what that means there. All right, let's look at example 2.